So, all right, I think we are live now. So, welcome everyone to the Keeping Data Science Broad series. I'm Dr. Renata Rawlingsgoss, the co-executive director for the South Big Data Hub. And the South Hub is one of 4 hubs for the nation for innovation around big data that includes industry, academia, and government partners for bettering society through data. There's the West, the Northeast, and the Midwest. And so the South is 16 states, Delaware to Texas, including DC. This series, Keeping Data Science Broad, this webinar is the second webinar in the series, where it's really focused on the engagement of primarily teaching institutions, which can be four-year liberal arts colleges, community colleges, minority-serving institutions, as well as alternative places of education around data science, including museums, training programs, as well as mentorship. So today is exciting. We have some fantastic panelists. The first series was on traditional context, which you can go back to our YouTube channel and watch. And this one is on alternative mechanisms of data science education and how we can really keep data science the broad discipline that it is in touching so many industries, as well as increasing the amount of different people and institutions that get involved. So I'm chairing the Education and Workforce Working Group, which this series is housed under for the South Hub, which is including people from all around the country, actually. So all of the hubs being involved, and we have representation of all the coasts, the Midwest, the Northeast, and the South and the West. So first up, we have actually, I'll do all of the panelists, and then first up we're going to have Lior Shimur, who is an associate professor at Lawrence Technical University. He has been working and doing a lot of exciting work with data science and teaching it outside of STEM disciplines. We're going to have Sarah Stone, who is the co-executive director for the eScience Institute at the University of Washington, and also working with the Data Science for Social Good program. We'll have Al Heron, who is the assistant director for the IT group at the IT department at the Breakfast Group, which is a mentoring institution and a mentoring group for African-American males going from high school into college years. Tracy Teal, who is the executive director of Data Carpentry, which provides 2-day trainings and boot camps all over the world in data science. And Stephen Uzo, who's the chief scientist at the New York Hall of Science. So we're going to start off our fantastic group with Lior to give more of an introduction and tell us more about your work.
All right. Thank you, Renata. Can I start?
Please do.
Yeah, thank you. So I'm Lior. I'm, like you said, associate professor of computer science, Lawrence Technological University, also assistant dean. And I've been with the Big Data Hub since day one, actually, and I'm still around. And in the context of education, I'm mostly recognized with the teaching through research, using research for teaching at all levels, whether it's undergraduate level, graduate level, non-STEM courses, and now going into the K-12 level, to use research as a tool for teaching. Let me share my screen with you so you can see the slides. So I hope you can see the slides. So basically, when we think about research experience for students, what comes to mind is a student working with a professor, helping him or her to do the work in their lab. And that's not exactly what I'm developing, what we're developing here. What we're doing, we're making it scalable to a large number of students, so many students can participate as part of the curriculum. So it's not extracurricular activities, it's part of the curriculum, and it's accessible to all students. And there are a lot of literature about the impact of research experience. It's one of the most one of the strongest interventions that we have right now, that we know about right now in higher education. These are some reports came from the White House back in 2012, where they identified that you reach better results and surely better engagement when the courses are designed as research courses and not just repeating what the textbook says and the results are in the textbook, but actually doing research in the classroom. So basically, the idea is to deliver the same materials that we learn in a regular course, but doing that through research, not through the textbook, but through research experience. Also, a lot of literature of the impact of research experience on underrepresented minorities, and it happens that the strongest impact of research experience is on underrepresented minorities. Lots of experiments, lots of literature about that. There are also reasons, I won't get to it right now, but actually the main reason for starting this project in the first place was to reach out to underrepresented populations in STEM. And these are so that leads us to CREO, a classroom-based research experience, doing the research inside the classroom as part of a regular course. These are the 5 elements of CRE. One of the important things, the ownership of the research. So the students don't necessarily do research led by someone else's research program, but they actually own the research. It's their part, and they lead that research through the course. We're doing that for senior or graduate level, introductory level, freshman, sophomore level courses, core curriculum courses that are not data science courses. I'll get to that. And now working on the K-12. So here's the first example I would like to show. That's an example from a graduate course, actually. So the purpose here is to analyze employee compensation. So the employee compensation analytics, the employees actually are soccer players, well-known soccer players. Why? Because first of all, it's interesting and it's engaging. It engaged the students, but also we had a lot of data. Data are available. So and that. Through that research, we actually cover descriptive analytics, like testing how the compensation responds to the skills of the soccer player. Also predictive analytics, we can predict how much a soccer player can make based on their skills. And also with further analysis, we also get to the prospective analytics. What skills do soccer player need to improve their compensation, to get a higher wage. And through the course, we cover all that. Actually, that also, and one of the students also published a paper about it, and it became, just recently, it became pretty, it made it to the news in Europe, mainly in the UK. So that was a nice example. That example is less comprehensive. It's a senior undergrad example of analyzing astronomical databases. So basically taking very large databases and annotating them, classifying them, understanding what's in them. So that example is not as comprehensive as the graduate course. Also, there's a lot of real world problems working with noisy data, because these databases are not as clean. They're not really close to textbook databases. And we also do some things at the introductory level courses. Here's one example. That's a freshman level course analyzing lyrics of the Beatles using data science tools. So basically, the students can create their own database. They go get the lyrics of certain songs. They annotate the lyrics. It's a fairly simple level. That's a freshman level course, I remind you. Then organizing the data, putting the lyrics in files. Files correspond to the spreadsheets that they have. Then they analyze the lyrics quantitatively with some tools that we developed. So those tools extract all kind of descriptors of the lyrics, and then get to the analytics part, and finding the statistically significant features, looking how the lyric style changed between different authors, different songwriters, Lennon, McCartney, how it changed over time, what changed over time, doing the statistical analysis of that. So that covers a lot of data science tools, but in a fairly simple, straightforward way. And again, while doing research, because that way of analyzing lyrics, either the Beatles or any other songwriter that they choose, it's a new way of doing that. And also, that's actually what we did first. We started with core curriculum courses that are not necessarily STEM courses like humanities. I'm going to show you one example from humanities, because that's an art history course. And how do we do data science in art history? So what do we do here? The students come up with some hypothesis that they have about art. They need to come up to select their favorite artist or favorite artistic style and come up with an hypothesis about it. And then they test it using computational tools. So we have some computational tools that we develop for that, and some that we use from other places. And we combine those into a process that the students collect the art samples. So here are examples of several simple hypotheses. So they collect art sample. Let's say if you look at the middle graph, these are all produced by a computer. So you see that the students collected about 50 paintings of Indian art, 50 paintings of Chinese art, 50 Italian art, and 50 French art, and then they let the computer analyze the art automatically and see if the hypothesis they initially came up with is really supported by the analysis of the computer. And that's an example of actually the class. The entire class, we combined, they combined all the students' work to let the computer analyze that to create that graph, and then they discuss it in the class. But they're using quantitative tools. They're using tools that we developed to do that. And here again, that's these are other experiments. On the left, I'd like to see how art changed over the years. Did either a progression of art is a link of progression. The left, the graph you see on the left clearly shows the computer can identify that progression, and that the hypothesis happens to be true. So that's a new way. And in the links that I provided with it, you'll see there are some videos taken in the class, so you can see in the classroom how it's done. It's pretty interesting to see, I think. There are some assessment results for that. That's the question is, do you enjoy class assignments? Do you enjoy course assignments? And we can see that there's a statistically significant difference when we use that over the traditional art history courses that we don't use data analytics. Another example, that's from psychology. So in this case, we're changing a freshman level introductory psychology course. The students collect Facebook posts. So first of all, they need to create a database using spreadsheets. So they collect the Facebook post, they create a spreadsheet, they annotate the posts, and they create their database like this. And then they end up with a database. Then we combine all the students' work is combined to one big data set. And then we analyze the data set. We using some text analytic tools, we analyze the post, correlate the post with the annotations, and starting to see if we can quantify differences between different posts, different topics, the age of the person writing the post, all kind of questions like that. And the students are divided into groups. Each group come up with their hypothesis, and they test the hypothesis using the data and using data science tools. They have some preliminary findings, and the purpose is not necessarily to discover something. It's basically we use research for student engagement, but it can also lead to discovery. We actually discovered several things while using those courses, and several papers were published about it. So that's also a nice byproduct to have. And also some assessment for that. The question, I prefer lecture to hands-on experience in the class, and we can see that the treatment group is there's a change compared to the control group. So thank you very much. I hope there's time for questions later, if there are some.
So thank you, Lior. Yes, so there will be questions at the end. Actually, we encourage people to use the live chat that's available right now on the YouTube channel and to ask your questions. We will look at them and ask them of the panel at the end. So once we go through and have people speak, we'll be looking at those questions and I'll ask them at the end so that we can go through. But I really like the idea of students being able to make their own question, to kind of form their own hypothesis and test it in the classroom. I think that's a fantastic way of getting them really involved and engaged in the process, and it not being a data science class. You know, that was really a freshman psychology class or an art history class. So I'd like to move to Sarah Stone, who's coming to us from the West Coast, as we talked about, as the co-executive director for the eScience Institute and many other roles. So Sarah, welcome.
Thank you, Renata, and thank you for inviting me to be part of this panel. I'm really excited to be here. And so as Renata mentioned, I'm the co-executive director of the eScience Institute, which is on the UW campus. I'm also the deputy director, one of the deputy directors for the West Big Data Innovation Hub. And so Renata and I have been working closely on a variety of activities. And so that's been a lot of fun. So I'll go ahead and share my slides. And let's see. Okay, so are those showing up?
Yes.
Okay, great. So let me move through this. So today I'm going to be focused primarily on our Data Science for Social Good program, but I wanted to start by providing some framing about the eScience Institute and our mission, because we do a lot of different data science education related activities in addition to Data Science for Social Good. So the eScience Institute, our mission is to accelerate and facilitate data-intensive discovery across all fields. So we're really a neutral entity on the UW campus, and we're one of 3 data science environment institutes that were generously funded by the Moore and Sloan Foundations, the others being UC Berkeley and NYU. And our institute, to some extent, is structured around working groups, and one of our working groups is data science education. And this group has been thinking deeply both about the development of more formal education curriculum, which was kind of the focus of last, well, I guess it wasn't last week, but the last webinar. And so you can see here the data science working group has helped to create a template, kind of a framework for the development of data science options that sit within home departments. And these have been created both at the undergraduate and graduate level, and we're having an increasing number of departments develop these options. Again, the departments, there's a lot of flexibility on these options, and so there's kind of a template, but then departments can figure out what courses make the most sense for their particular programs. And so it's a bit of a different model in that those options, that they are transcriptable, but the student is still getting a degree in their primary discipline. We've also been involved in creating a data science professional master's program. And again, at this point, we have 9 different departments or units on campus that are participating in these programs, and this number is increasing every year. And a lot of these courses are open to students from across campus. So even if a student isn't able to get the transcriptable option, they can participate in these courses. And many of the courses that are coming online don't have any prerequisites. So these are courses that an incoming freshman could take. Notably, we have a data science and society course that's being offered through sociology, starting actually next week in the fall quarter. And that's a new course coming online. We also, which is kind of more the focus of today's webinar, do a lot of what we call kind of ad hoc data science education programs. And these include kind of quarter-long programs like the Data Science for Social Good program that will be more of the focus today. We also run an incubator program, which is a similar format, but it's during the school year. And then we sponsor mini hack weeks. We actually just wrapped up Astro Hack Week, Geo Hack Week, and Neuro Hack Week in the past few weeks, and other kinds of short tutorials. We are an active partner with Software Carpentry, which Tracy Teal will talk about later, so I won't belabor now. And then we also do things like office hours, drop-in programs. We really think that these ad hoc education programs help to fill the gaps in data science education. We know that many folks, they may be later in their careers or are not able within the context of their education to participate more fully in these kinds of data science curriculum options, but being able to participate in a short-term program, be it 2 days or 10 weeks, allow them to gain an important skill set that is valuable, as we know, across all disciplines. So diving more deeply into our Data Science for Social Good program, this is run again out of the eScience Institute. The goal of this program is really twofold. It brings together students from across the country and provides an educational opportunity. And I really liked Lior's emphasis on this it provides a hands-on training for students with real-world data, which we all know is messy and complex. And so it provides that sort of hands-on training working with real-world data. And then at the same time helps to advance research projects in this kind of social good space, which we think of very broadly. And hopefully that research will then help to facilitate responsible data-driven decision-making. And our program was modeled after the first DSSG program, which you guys may be familiar with at the University of Chicago. Georgia Tech also has a program that I know Renata is deeply involved in. And we also modeled this after our own data science incubator program, which we've been running since 2014. Our Data Science for Social Good program started in the summer of 2015, and so we've just wrapped up a few weeks ago the third iteration of our program. When we think about these Data Science for Social Good projects, there's sort of this coupling. We have a broad list, and this is not a comprehensive list, of domain areas of interest. These are the kinds of topics or fields that we tend to get project proposals from. Again, this list is quite broad, and we haven't yet covered all of these spaces, but these are the areas we're interested in, projects we're interested in trying to bring in. And then I won't belabor this, but we are looking for interesting areas in terms of the technology. And so, we're excited to work on new platforms, new algorithms, developing new methods. Obviously, we work with a lot of messy data. Many of these projects end up involving some sort of interactive visualization. Often that visualization is going back to the stakeholders, either in a public forum or in a limited capacity to the stakeholders who are deeply involved in those decisions. This is sort of our laundry list. So to date, we've run this program 3 times, as I mentioned. Each summer, we take on 4 projects. This is just to give you an idea of kind of the breadth of projects we've covered to date. We have had a strong focus in transportation, and that's partly due to having some really strong transportation-oriented groups on the UW campus, including the Taskar Center for Accessible Technology, who's been involved in many of our projects over the last few years. But we've also had interesting collaborations, such as looking at permanent housing for homeless families with the Gates Foundation, which has led to a longer-term collaboration. And we've also, more recently been involved with thinking more about neighborhood development in Seattle and equitable development. When we look at project proposals, so we do a call for proposals for projects that will be chosen for the DSSG early each year. We accept proposals from across sectors, so we do get proposals from academic researchers at the University of Washington. We also get them from the government, primarily from the city of Seattle and King County, nonprofit organizations, industry. And so we're very broad in thinking about, what kinds of, who can submit proposals. We're looking for, obviously, like you can imagine, strong science and strong methods. The person who does the proposal, and this is a very lightweight proposal, I should say, this is something on the order of 2 or 3 pages, but the person who submits that proposal then becomes what we call the project lead. And being the project lead requires participation, like active participation in studio with us 16 hours per week for the duration of the program, which is a 10-week program. And so that is a very high level of commitment, but we've found that that's really critical because we rely on the project lead, not just to manage the student, the teams that I'll talk about, and set goals, but the project lead is also the person who most deeply understands the data. And they provide that domain knowledge and data expertise, and really help keep us honest in what we do with the data and the goals of the project and how the output of that project is used by the stakeholder community. And so that leads me to emphasize that we find, that having established stakeholder relationships that the project lead already has in place are really, really valuable, not just for the success of the project, but also for the value of the student teams in particular, understanding the importance of stakeholder relationships, how difficult and sort of challenging, I guess, it is to navigate those relationships at times. But that's a really valuable experience because it is a very good preparation for what the students will actually be handling when they're out kind of in the real world in the workforce. We also look for measurable outcomes, and many of these projects have the capacity to continue to have sustained engagement and for us to be involved with them for many years to come. So I've mentioned the project team several times. This is what a project team looks like. So each team has 1 to 2 project leads. That's what I've kind of been talking about. This is the person who submits the proposal. They really help drive the goals of the project and the timeline, and lead the team. We also then have 4 data science for social good student fellows. These include graduate students and advanced undergraduates. I'll just jump to this. So in terms of selecting these students, we're very fortunate in that we get, typically over 200 student applicants for the 16 positions. And that's with not working very hard at all. So I think one of the things we've learned is there's huge interest among students in working in this social good space. And many of the students that we get are not from sort of methods, disciplines necessarily. They come from a diverse array of backgrounds, from the social sciences, the physical, natural sciences, humanities, but they're all interested in working in this space, even if it's just for the 10-week period of the summer. And so I think that's something to keep in mind in running these programs, that there is really a tremendous interest. Our commitment that we require of the students is that they spend, roughly 40 hours per week with us for the 10-week summer, and we do provide them with a stipend. We select 16 fellows, 4 are on each project. Again, these have to be current students, they're advanced undergrads and graduate students. We select them based to some extent on their educational experience and GPA. We look for a breadth of domain disciplines. We also do require some level of technical or analytical experience, but we've been very slow to really make exact requirements here. We're looking for quantitative experience, but that can look quite different from student to student. We also look for a demonstrated interest in social good, and this can be through their primary research or through paid or volunteer experiences. And then, ideally, they've had some experience in collaborative projects. Most students have had this in some capacity. And we look for some students who bring a human-centered design experience, just because so many of these teams end up developing apps or visualizations that it really helps to have that skill set. So we're often looking to have at least one student with some design experience on each team. So going back, so we have the project leads, the students, which I've talked about, and then on each team we have 2 of the 2 eScience data scientist leads. And so we're very fortunate at the eScience Institute to have a staff of data scientists that work for us on either a full or kind of part-time basis and help us to support a broad range of programs. And like the student fellows, our data scientists come from a breadth of different backgrounds, but they're all folks who have gotten interested in really more focusing on the methods development in data science, but many of them continue to be at the cutting edge of research for their domain disciplines as well. And actually looking at this picture from this student team, Ariel Rokem and Brenna Hazelton, who were the two data scientists on this project. Ariel's a neuroscientist and Brenna's an astrophysicist, and they were working on this project that had to do with family homelessness. So what's really exciting is to see that this data science skill set, as many of you know, really allows you then to work across many disciplines. And that can be exciting for all involved in these teams. Oh, yep, so this is our data science staff. And again, we're so fortunate to have such an awesome group of people participate in our program. You'll see down on the in the bottom right corner here, we also have a director of data science ethnography that's part of the eScience Institute. And the data science ethnographers, and we actually have a number of students, including Anissa Tanweer, who's been deeply involved in our program. And they are very critical to the success of our Data Science for Social Good program and really all of our programs at the Institute. They interact with the DSSG in a variety of capacities. For their own primary research, they're interested in studying the culture and practice of data science. They're interested in looking at how people collaborate in developing new technology. They're very helpful to us as an institute in terms of providing programmatic insight about our programs. And then they also lead tutorials for the students participating in the DSSG program, doing activities around stakeholder identification and collaboration, and as well as data science ethics. And these are done at a kind of a high general level and then a very deep dive into the individual projects that are chosen to address these topics. And you can see, for example, here, they work with these charts here where you're looking at the balance of stake and power for all the stakeholders who might be involved and affected by these projects. In terms of the program activities, the students arrive and the first 2 weeks are really filled with various different tutorials. We really rely heavily on running a software carpentry tutorial, which Tracy will talk about in more detail. At the beginning of the program, DSSG fellows either participate as helpers, kind of in helping to teach the software carpentry, or as student participants. And this allows us to kind of get a sort of more level playing field, so to speak, in terms of the data science skill set. Then we also, we have a variety of tutorials that include some of the ethics and stakeholder workshops, as well as other technical tutorials. We continue to do those throughout the program as needed by the particular project teams. We also have, every week we have what we call stand-up meetings. This term comes from industry. Stand-up meaning they're not long enough that anybody has to sit down, and we do project updates so that everybody across the 4 projects can hear what's going on in the other projects. And these are particularly focused around challenges, recognizing that we have a broad suite of expertise in the room, and often there can be sort of crosstalk between the different teams and solutioning across the teams. We also have a lot of social events integrated, like weekly happy hours. We encourage the project leads to arrange field trips to visit stakeholders, as appropriate given the project. And what you can see here, we're very lucky to have a data science studio which houses our institute, but also houses this program where we have a very flexible space to house this Data Science for Social Good program and the students for the course of the summer. By the end of the...
I'm sorry, Sarah. So thank you. I think that the program actually is so comprehensive, and it's a really nice way to get students involved in nonprofits and government. And it's a really nice introduction into how we would really look at trainings, which I think, so you introduced software carpentry, which Tracy will talk about later, and how the students get involved in a lot of the different projects, and even the structure, which I think is really helpful for how the eScience Institute does things and how the ethnographers, which is something that's interesting an interesting aspect that you don't usually see in a data science program. And I think it feeds really nicely into kind of mentorship programs, which is something that Al is going to talk about next too, about how to mentor students straight through. So all of those things are really nice ways of kind of reaching out beyond just the projects that we see in classrooms, right? So I really think the DSHG program is to be applauded, and the fact that it's done differently across the different areas of the country.
Well, thank you. Thank you. And sorry for going over. I should have been watching my clock more carefully.
Oh, no. So, so Al, our next presenter is Al Heron, who is, like we said at the beginning, the associate director for the assistant director for IT department, the Breakfast Group, which mentors African-American men who are in high school and on their way to college in STEM and other fields. So Al, welcome.
Well, thank you, Renata. Let's see here. Can you hear me okay?
Perfect.
All right, excellent. What I want to do is first say, Sarah, I'm not sure why it is we haven't met yet, okay, but we're going to have to change that, okay, very quickly. There's a lot of what you said that is directly applicable to what we're trying to accomplish at the Breakfast Group. So you should expect to hear from me. Okay? Now, excuse me, I don't have a set of slides, but I am going to direct my stream to the Breakfast Group's website while I talk. So I'm going to share my screen here. Let's see here, share on the tab. And then, so what you should be able to see is the Breakfast Group's website. It's at thebreakfastgroup.org, and I encourage you to go to that website if you choose to while I'm having this conversation, and just go through it and see what it is that we do and what we're about. Okay. The Breakfast Group has been around since 1976, and we're dedicated to education and economic development. And what I want to do in this conversation is to talk about, because we do mentoring, we've been doing it for quite some time. We have a few signature programs, and in those signature programs, there are a lot of volunteers. It's an all-volunteer organization, and we made quite a bit of progress over the years. So we're very good at what we've been doing, and we're in 5 high schools now, and the work goes on. But one of the things that you have to deal with is how you get a legacy organization like the Breakfast Group, which is still relevant today, and bring them up to speed on the explosion of requirements that are connected with data. It's data. Everybody wants performance data, and they want to see how it applies to any funding that they might provide you. So it takes a little bit of effort to bring everybody up to speed in the organization and to do things differently and in an improved fashion than you have in the past. So a few years ago, the Breakfast Group did come to realize that the growing need to focus more on internal resources on collecting this data across the board for its signature program, Project Mister. The IT department was formed. We brought in a couple of individuals, myself and another gentleman, Chris Webb, to form the IT department and then build the appropriate infrastructure around that IT department to support the entire organization, to support the programs our signature programs, and to support our members as they continue to do their good work. Okay? The IT department was tasked with making changes to this infrastructure and services to allow for systematic program reporting, technical support, and data management needs assessment services for our signature programs. What I want to discuss are the steps taken in accomplishing this task, and learn more about the political wins and community priorities and funding influences that drove the need for much greater prioritization of the collection of data as a function of organizational success. A little bit more of an introduction. The Breakfast Group is the oldest nonprofit, non-fraternity service organization of African American business and professional men in the Northwest of the United States. The group has been active in Seattle African American community for more than 39 years, attaining to some fairly significant success. Along those lines, we value a consistent, competent, and reliable presence in the lives of the youth we serve. So we have to model for those youth what it is that we would hope that they would strive for in their post-high school lives. Our organization empowers African American and other low-income, at-risk male youth of color by imparting the values of responsibility, leadership, and accountability. Our mission is to provide effective leadership for African American and other at-risk male youth of color towards the achievement of academic excellence. So, outcome measurements when we're driving a program become significantly important once you start to get into certain kinds of funding. One of the things that the Breakfast Group has been quite capable, quite successful in doing over the years is working with different organizations and corporate entities to raise funds to support Project Mister, with our All Achievers program, and our Taiwan On Luncheon, which is a celebration of the progress and success of the students that we work with. And very successful in doing that. In recent years, in looking for additional funding to expand what the organization does well, we realized that in working with entities like the city and the county and the state, that the data requirement, performance data requirement, in order to both apply for funding and to support the maintenance of that funding, that was growing. So our next step was to realize that we had to make clear that the programs that we promote and support are evidence-based programs. We had to have evidence-informed curriculum development, which we have been growing. There need to be some consistency and expansion of the cohort size. And that means that rather than a few students at a time, we need to reach out and seek to grow that to 10 or 15 students per cohort. And we need to collect all the data that's required for reporting on those cohorts in a systematic and reliable and consistent way. What went along with that were data sharing agreements between different organizations that we work with, and with the school districts, and as well as with the city. Nonprofit organization collaborations became even more important, but also a bit more difficult and challenging to accomplish, given the requirements for collecting the proper amount of data and reporting that in a way that was acceptable to the funding organizations. Now, the Breakfast Group itself is a 501c3, but one of the things that we took advantage of was a collaboration with the Urban League of Seattle, and they became our fiscal sponsor. That allowed us to have the Urban League focus on the relationship with the City of Seattle and the contract, and for the Breakfast Group to work with its instructors in making sure that the programs were properly delivered, and we had the appropriate amount of recruiting and consistency in delivery of our curriculum. Data collection, analysis, and reporting became a regular and steady part of what it is that we do. Now, it's true that the Breakfast Group has been doing this for years, but as the years have passed, it's become less about hard copy data collection and more about electronic data collection, and then making sure that that data is properly stored, properly collected, stored, analyzed, and reported. Increased need for organization data security and policy development became a part of it. and an increased need for training members and program instructors on that same security while having to collect all that data and properly present it. So that was our challenge. We expanded the IT department and its function. We expanded the training that we needed to do. And all of this was before we even get to having students involved with focused STEM enrichment activities. Once we get to this point, beyond the data, we would normally collect on the success of programming for our life skills, urban community awareness, community engagement, and indirect classroom performance impact. That meant that we also must prepare to add direct testing measures as a part of the STEM enrichment programming and properly collect, store, analyze, report, and protect this data as well. So this was the journey that we had for the Breakfast Group over the last few years. We're very much getting to where we need to be, but we're also seeking to continue to collaborate with organizations to improve how we do that. And I see that as something that we're going to be very successful with. So that is my short presentation.
Yes, thank you.
An introduction to the Breakfast Group. And I'm hoping to get the chance to answer some questions a little bit later and see where this webinar takes us.
Thank you so much. Yes, so the Breakfast Group is really a long-standing institution, and how data is now wrapped into your students' learning, but also into your organizational process. So I'm really interested, as people think about, if you're working with nonprofits or any business really now needs this data component, and what types of questions you might have for Al. Please, people that are watching, put them in the chat. We'll asking of the panel later, and then we'll go back. Al, I think you're still screen sharing, so you can.
Okay, so let me break that off. How about that?
Perfect. You
okay,
got
cool.
that. And so now we're going to transition into Tracy Teal, who we've gotten some preamble for already with Data Carpentry, who's going to tell us about their program and how they're helping to train around data science in kind of a unique way as well. Tracy, you're still muted.
Yes, great. Thank you so much. I'm really glad to be a part of this webinar. A lot of great ideas already, and excited to continue to hear more and continue this conversation. So I'll go ahead and share my slides. So as Renata said, my name is Tracy Teal, and I'm the Executive Director of Data Carpentry. And I'm going to be talking today about software and data carpentry, and how, like a lot of these other programs, we're looking at doing training sort of outside some of these other more traditional pathways. And so I really want to start, in these things, we all kind of say the same thing, and about how data is so important in where we're headed. But big data now is really for everyone, in the sense that data is available in so many domains of research and life, and even in your Amazon collections or your Facebook posts. And I really liked Lior's reference to, art history. So there are really opportunities to take advantage of data to answer questions that you care about everywhere. But instead, usually, of people being excited about the opportunities that data present to them, they're instead quite sad or angry, because it's not necessarily very easy to figure out how to make use of this data. And so the question is, how do we scale data literacy and data skills along with this really big data production? And so, this is really the theme here of this webinar, where we talk about training in the gaps. And so what I'm going to focus on is short intensive training, so workshops, short courses. And the reason for that is that they can provide more training opportunities. So semester long courses are really great and integrated into university programs. So that's terrific. But in terms of the scaling, often they can't get through maybe as many students. Someone might build a great program at one university, but not have it available at other universities. So these shorter workshops are something that can be deployed broadly and made available to more people. And so data and software carpentry workshops, that's what we do. We provide what we teach in our workshops. So we teach the foundational skills for you to work effectively with data and do software development. So when we talk about a workshop, we're not trying to teach everything. We're really trying to focus on getting you started. So the skills that we teach are around data organization, data wrangling, right? So Sarah alluded to the messy data of the real world, data analysis and visualization in R or Python, and software version control, so GitHub. And these are the skills that we teach, but even more importantly than these skills and walking away with a set of skills that people know, is that people walk away with an awareness that these types of approaches exist and that they have the confidence to continue to use them. So I also really liked, how Leo talked about how they showed how you could use these skills in a particular context, because that's really what gets you excited to learn more when you see what's possible. Often, if you haven't had an exposure to these approaches, you don't even know that you can do these kinds of things or ask these kinds of questions. So how is it that we teach skills and build confidence in 2 days? And so what we do, they're 2-day hands-on workshops. So I think all of us here have emphasized the importance of the hands-on component, so to really get experience with the tools. So all of our workshops are hands-on. We follow an I, we, you model where an instructor talks about a skill and presents it. We do it together with the instructor and the students, and then the students try it on their own. So it gives opportunities to try and get feedback as they're learning. We also really work to create a friendly learning environment, especially around computational skills. A lot of times the people have had sort of disempowering experiences trying to learn these things. Either they've gone to a course that wasn't really the right match for where they were or what they wanted to learn, or had some experience that made them think that computational skills weren't for them. So we really emphasize within our workshops creating that friendly learning environment and meeting people where they are. All of the lessons that we develop, so we have lessons on all these topics that we talked about. They're all collaboratively developed and openly licensed. So they're all online, available for use and reuse and adaptation, anything anyone wants to do with them. And they're collaboratively developed. So they have, in some cases, hundreds of contributors. And the great thing about that is that we're constantly teaching these materials, getting feedback from people on how it went and how we can improve the lessons. So it's not the case that you develop a course for your semester, you teach it, then you come back to it the next year. We're constantly teaching and iterating on these lessons and trying to improve them. And when someone goes to teach, they're not starting from scratch, right? They have these materials available to them to teach. And finally, and this is what I'm going to emphasize a little bit, is our volunteer instructors. And so we have volunteer instructors who teach all of our workshops. And so these aren't necessarily people who are professors. They're graduate students, postdocs. They're people who have these skills, often are domain researchers themselves, but they really want to share these skills with other people because they've seen what they can do in their work and want to empower other people to use them in their work. And using this model, this 2-day hands-on workshops, collaboratively developed materials that we use in every workshop, volunteer instructors who go and teach. This workshop model has been really successful. We've run hundreds of workshops all over the world on 30 countries. And these are some of our long-term survey results. So looking at people after 6 months or more after they've taken a workshop. And so we see two important things. One is that we see that people are using the skills that we taught. So this chart on the left with the blue and red bars, people are talking about how often they use programming skills before the workshop and after the workshop. So we see increased usage of these skills in people's works. The other really important thing is that we see a vast improvement in confidence that persists even after the workshop. So you could imagine that right after a workshop, someone feels like, yes, I really know this, they feel really excited, but then as time goes on, their confidence decreases, or they don't have opportunities to use it or find it's harder than they thought. But in fact, this improved confidence continues to persist 6 months or more after the workshop. And that's really the foundation. And Doane College is also doing a really nice program for undergraduates in training. And they really emphasized in their surveys that self-efficacy and confidence are the most important. They never see a skills increase if they don't see a confidence or a self-efficacy increase. So we have to really start there with exciting people about these skills, empowering them, making them feel confident that this is something they can do. And as I said, you know, our instructors are key to this. And one is really the passion that they bring, and the other, and also that they scale, right? So I mentioned that we'd run hundreds of workshops all over the world. So that obviously wouldn't work very well unless we had a lot of people to go and do that. So we have an instructor training program. And that instructor training program has run, actually on next month, we'll have run 100 instructor trainings. And that instructor training program teaches people how to teach. So it's based on educational pedagogy. So it also is a 2-day workshop. So it's teaching people how to teach, and it's teaching people how to teach computational skills this way, with this really active learning component to it. And I kind of liken this, this train the trainers model for scaling data training as a first aid approach rather than the firefighter. So right now in data science, we have kind of this firefighter model where we have these people who are really well trained, you know, maybe they know machine learning and Hadoop, and we sort of think that we need this firefighter to train and deploy on all of our data science problems. But in fact, a lot of the questions that we have about data require basically that you understand what data is, that you can do some data manipulation, start to get insight from data by doing plotting. And so instead of actually working to train more of these firefighters, what we can do instead to really scale how we work with data and people training around data is we think about it as this first aid model, where we're giving a lot of people these sort of starting skills to help in the field wherever they are, right? So you look at the impact that something like the first Red Cross first aid training program, the number of people who've gone through there that are the people on the ground when something happens that can do the CPR, that scales much better than these firefighters. And there are different sets of problems that people need to approach. Obviously, we still need firefighters. But if we think about things a little differently in terms of the level of training and how we reach people, it kind of shifts how we think about scaling training opportunities. So I mentioned with our instructor training program that it teaches how to teach. But the other really important thing there is that it builds the local capacity for training in building communities. When you train instructors to teach at an institution, they can then teach themselves. And they can teach other people in their community. And it helps to build a community of practice, a set of people that they can look to who are using these skills. They can continue to work together, and changing that kind of the culture around data science is almost as important as giving people the tools. So how can you get involved? So right, Sarah mentioned a lot about running the software carpentry workshops at University of Washington, right? And that's a great example about building local capacity, right? They've really taken the software and data carpentry and built this program around running continued programs, instructor trainings, and workshops. So becoming a member of organization is what really facilitates building the local training capacity. You can also request individual workshops, though. You can become an instructor as a part of this program, contributed to our collaborative lesson development. So there's a lot of different ways, depending on what you're excited about and who you're looking to serve, to be involved with our organizations. So we've been supported by some of the National Science Foundation and the Gordon and Betty Moore Foundation in particular. That's what I wanted to talk about today, and I'm looking forward to any questions that people might have.
Thank you, Tracy. Yeah, so I'm interested, do you know how many workshops we'll also, we see we get some people, but thinking out as we're coming to the end, putting your questions in the chat for all of the participants. Also that we're definitely excited. Yeah, you're still sharing, I think, Tracy.
Yes, I was gonna, if you had questions about numbers, I do have my numbers screens up so I could show you, but.
So we're gonna do it at the end.
Perfect.
Just to give a heads up about, you know, how like the members or the breadth of people in all of your programs that are kind of being impacted, and what kind of the demographics of those are, whether it's more diversity you see in these alternative programs, sort of a similar breakdown, so like a traditional computer science type discipline, or where you see data science being different. So any other questions too from the audience? We're looking at your questions as well right after our last speaker. And the South Hub is very interested in data carpentry. I think we're looking to host, to have an application process for people to host and request data carpentry training in the region, especially communities and universities that are a part of this series, or thinking in the same thing of community colleges, small liberal arts colleges, alternative training programs that really affect and broaden the amount of people trained in data science. So last but definitely not least, we have Stephen Uzo, who is the chief scientist for the New York Hall of Science, which is a museum, which is doing fantastic things in the realm of education and with data science. So Stephen, welcome.
Great, thank you. So I'm going to share my screen. Everybody can see this, I guess?
Yes.
Okay, so I'm here from the New York Hall of Science, as Renata mentioned, and we are actually a member of the Northeast Big Data Innovation Hub, and we've been working on a big data literacy project to help bridge the gap between data-driven science and technology practice and public understanding of big data and big science. So we're a little bit different from a lot of the other kinds of projects in that we think about everybody, not just undergrads, not just lay people, but sort of all of the different areas. The New York Hall of Science is one of the city's cultural institutions, and our work over the last decade and a half has been centered around bridging the gap in big data and public understanding and data-driven science in the form of network science and big science, and more broadly big data, including a new exhibition on big data that we're working on, and an initiative we're calling Big Data for Little Kids, which is a series of workshops to study data literacy skills in very young children. We also held, which is possibly the first public festival on big data back in 2015. So I guess let me start by just reviewing where this gap came from and how we got into this predicament of science moving in one way and education moving in another. As you're all aware, we live in an age in which traditional science, in fact, every sector, every aspect of human culture is flooded with data. So believe it or not, this transformation was preceded by a period in which the future of science was in doubt. At the 6th International Congress on the History of Science, Dirk de Sola Price predicted the exponential growth of science would make research so complex and costly we would soon exhaust our ability to support science as an enterprise, when gathering data was hard and also expensive. But Moore's law took care of that problem, and by the turn of the millennium, our ability to acquire, process, and store data accelerated rapidly, obviously due to advances in computer power, but also cheap and automated data capture systems for everything from DNA sequencing to remote sensing. We're now gathering data at such a fantastic rate, we're drowning in it. Science engineering have been transformed, and we're now facing a kind of Moore's law for data-driven science, which is an exponential growth in what Jim Gray called the fourth paradigm of science research. In an era in which computer users worldwide generate enough digital data every 15 minutes to fill the US Library of Congress, our ability to gather data has vastly outstripped our ability to analyze it all. The effect of this trend is reflected in the transformation of the workplace throughout domains. The kinds of skills demanded by everything from startups to Fortune 500 companies to research labs have dramatically shifted away from a focus on individual compartmentalized skills and hierarchies to nimble, highly creative, collaborative, interdisciplinary, and analytical skills. The kinds of questions we ask of ourselves, the degree of complexity of nature at all scales, and the complexity of the problems policymakers, industry, and citizens are called upon to address are increasingly interdisciplinary and complex. The routine, manual, and repetitive tasks are either completely automated or no longer relevant, and there's no indication this trend is not going to continue at a rapid pace. Some of the kinds of skills that big data demand include emphasis on design, construction, visualization of large-scale data, as well as federation of multivariate data streams through computational analysis tools, enhanced exploratory, stochastic, pattern-seeking, and interdisciplinary approaches, machine learning, semantic and ontological analytical processes, and leveraging of cyber infrastructures to make large data structures more available and interoperable. Yet the demands on our education system are the same as they were back in 1950s. Data sciences are not taught at any depth except in small specialized programs. They're increasingly emphasized in standards, but uptake has been slow, and this lack of penetration threatens the pace of technological, scientific, and engineering progress. We have the opportunity to transform human knowledge along with big data to bring the public along with us, which is not only the most ethically responsible thing to do, it's the only way this process can continue at a rapid pace. Without a big data knowledgeable public, policy, and education sectors, we're building ourselves a house of cards that will fall purely from the lack of skills and intellectual prowess. This was the impetus for us to put a stake in the ground around big data literacy and start a process to build capacity that could scale through all data domains to close the gap between all of you that are listening and everybody else out there. To accomplish this, we brought together experts from partner institutions of the Northeast Big Data Innovation Hub and elsewhere in a process of collaborative inquiry to A, focus big data practitioners around learning, B, identify the nature and quality of extant big data literacy resources, and C, to look at the kinds of strategies that could advance big data literacy for lifelong learners. In an ideal world, we would have found many amazing resources and programs that would just need to be brought together with the public in better ways. And we would already be cultivating a generation of data literate individuals who can pursue academic and work careers in big data and advance our work in ways we can currently only imagine. But indications are that, maybe not including some of the programs we've been talking about, but for the most part, the resources are pretty inadequate to help the public understand what big data is, how it works, and what the effect is on their lives and the people around them. And there don't appear to be adequate academic programs to support workforce development and align the skills and competencies our citizens need of the scientific and technological workplace. To figure out if these intuitions were correct, we started a collaborative process by assembling an inquiry group to research and explicate the state of big data learning. Collaborative inquiry is a kind of action research that starts by circumscribing the problem, in this case, defining the state of big data literacy, then taking action based on the initial proposition to explore the state of resources, programs, and projects that exist to support the understanding of big data across audiences and learning settings, then convene to debate the validity and significance of these results, and finally reflect on the implications and impact of the original question to determine whether the process needs revision. We then brought them together with other data scientists and learning experts in a workshop in the spring to validate conclusions and look at what it would take to fill the gap between this assessment and big data practice across all settings and domains of work. The outcome of this process helped validate the need for and to identify an emerging community of practice around big data. And it also revealed the following. An advanced big data literacy is essential in a society, and there's a willingness among practitioners to envision a way forward. An inclusive, collaborative, multi-sector, multidisciplinary approach is needed to develop a bias-aware and unified framework and sustainable infrastructure that will allow for big data literacy project implementation and oversight. While there's a need to specifically target the Northeast, there's clearly a global need for big data literacy, and scalability and generalizability are important goals. And finally, the breadth of expertise and interest in equity, ethics, and in bridging sectors and educational opportunity areas represented by workshop participants could be brought to bear on circumscribing the big data literacy and developing a practical framework. We're currently in the process of digitizing the output of this, analyzing it, and working on compiling a report, which we would put up on the Big Data Innovation Hub website in the near future. So the next phase of this work is to develop a straw man, which can be used to draft a framework for big data literacy. This process will be based on a successful process we've used in the past to gain consensus around science disciplines or areas of literacy concern that can be infused into learning standards, inform curriculum development and instruction, and ultimately help result in a more literate population. The grassroots progress that we first used to develop a set of ocean literacy principles a little over a decade ago, and it's quickly followed by other complex disciplines. And most recently, we adopted this approach to develop a set of network literacy, essential concepts, and core ideas. So we'd like to create a similar kind of concise structure to frame big data literacy and inform a set of essential concepts that could be used to develop such a framework and target resources for big data literacy. We're continuing to work on getting the support we need to create and disseminate such a framework for big data literacy. And we're seeking partners to join this effort. Of course, we're very interested in the work of all the hubs and making this an inclusive process. So I'd like to invite not only the people on this panel, but those listening and those in the South Hub and other hubs to really think about joining this effort and contacting us so that we can begin this important work together. I'd also like to acknowledge the support of this project under National Science Foundation SIZE research area for Division of Information Intelligence Systems, and also additional support from the Northeast Big Data Innovation Hub. I'd also like to thank the Southern Hub and Renata for inviting me to present today, and all the members of the Northeast Hub that participate in this work. Thank you.
Thank you, Stephen. Yeah, so I mean, the work that you're doing here is key and kind of core to the mission here of looking at what are the skills that are really needed in data science. And we found that to be very broad and very industry specific. So having core skills is something that I think we all in this call are pretty interested in. And I know that keeping this discussion and this particular group going is something that we're taking up as the South Hub. So there will be in-person convenings, as well as in the chat here, there's a community input form that actually asks about your views on how to broadly include. So directly in the YouTube channel, in the description of this particular one, you can click to the link to the community input and share it broadly. We'd like to put together a report as well in connection with several different education initiatives around data science to look at this broadly and to get as much feedback as possible from people doing it and using it and interested in data science and seeing it. I have a colleague that I think, Al, you know, that says that everybody, every company now and most nonprofits, no matter what your core mission is, you also need to now be a data analytics company and possibly a cybersecurity company.
And one of the things that we've had to do is get serious enough about it that we've hired subcontractors to help step up our game more rapidly so that we can take advantage of available funding.
Yeah, so I mean, so this I'd like to open up to some of the questions that we talked about, but really this key issue of data literacy and then also the workforce component of how to broadly train the workforce needed to keep innovation going in this country and around the world with that. So one question that we did get was specifically around data carpentry and how you do assessment. So how you assess your students to ensure that they're competent and whether they get any credit or continuing education or badges or anything like that to show that they've completed one of your courses.
Great. Can you hear me okay?
Yes.
Okay. Okay. Thanks. Those are great questions. So I'll take the assessment question first. So we do have someone on our team on assessment, Carrie Jordan, who was going to also be on this call today, but is in fact teaching. And so we do 2 types of assessment. So we do one pre and post workshop survey. And so that's assessing feelings about the workshop, as well as self-reporting skills before and after the workshops. And then the other one is the long-term survey, and that's the one that I showed the data from, which is 6 months or more out. So actually, if you go to the datacarpentry.org/assessment, you'll see all of our assessment materials there. So our surveys and our short-term survey report, and then I'm not sure if the long-term, I think the long-term survey report's also linked from there. So we have primarily been relying on self-reporting and doing non-paired assessments, but we've now just developed a new instrument that will allow us to do paired reporting and has some actual skills-based questions that are not self-reporting, but actually are checking those skills. So we'll have a little bit more information about skills going forward. I don't know if there's other assessment questions, so if there are, please put them in the chat. And then the second question was about, badges and certificates. So actually, no, we don't really provide anything around learners having taken the workshops. We do sometimes give completion certificates or letters that people have taken those, because some people do require them for continuing education. But we don't have a program where we say, we certify that you've learned these skills. And the reason for that is, one, we don't want to create a test because that often does not make you feel like you're leaving having learned things. And the other is that we're not really sure exactly what would be in that test when our goals are not just around skills-based, but about preparing you for continued learning and learning how to look for help and do troubleshooting. So probably going forward, we will be a little, provide more of these sort of certificates of completion, but we don't have any plans to do something like test if you've learned these skills in a workshop.
Nice. So I'd like to open the assessment question to the panel. So for your programs and your different efforts, do you have any means of assessing kind of what skills you want your students to come out with and kind of tools for doing that assessment? So you have to unmute.
Yes, this is Al Heron. I immediately went to the website for the instruction, and I can tell you that based on what I've read, given the data literacy, financial literacy, and STEM literacy combination that we are bringing to the table for our students, that it seems to me, and I need to learn more, it seems to me that this would be very well placed in helping bring our organization and our students further into the world of data literacy. That's my immediate impression.
So thank you. So I guess I'll just go down the line from what I see. Lior, do you have a method of assessment or assessing from your different programs?
Well, a lot of our main goal is basically engagement and self-efficacy. We use surveys, we use entry and exit interviews. We have external evaluators helping us doing that. Our project is actually bigger than just data science. I talked about data science here, but we're actually changing the entire college. So it's a more comprehensive program than just the data science, and the assessment is in that context. So it's a comprehensive assessment too.
Great. So you're looking at not just data science, but kind of infusing different aspects into your curriculum.
Right, and it's about inclusion. It's about, like I said, it's engagement, self-efficacy, identification as STEM professionals among the general population of students, but also among underrepresented populations. So it's the project is just like you said. It's not just data science, but not the goals are not necessarily just to train data scientists. We have a bigger goal, which is STEM in general.
Mm-hmm. Nice. And so, Sarah, similarly, I know the eScience Institute, but then also DSSG, but then they're not the same in how you assess whether students come away with a good experience, and also if part of your goal is it part of your goals to be similar to what Lior is saying, to kind of increase diversity and inclusion around data?
Yes, for sure. So we similarly, as what's been talked about, we do assessments both so this is particular for the DSSG program. We do pre-program assessments that include both kind of technical skills as well as other kinds of factors, like things to do with the domain knowledge they come from and kind of their career aspirations. And then we follow up on that at the end of the program. So we're looking both at program success, but also, in terms of teaching the technical skills, but also how that kind of changes the framing of what students want to do with their lives. And we also often find that there's really a shift in either the focus of the type of research they want to do, or kind of where they want to spend their lives in academia versus going more into the social sector, because they have this experience really making a difference. And so that's super exciting to see. And I think, was there a second component of your question that I haven't touched on yet?
Not mine, but the second component was whether you give badges or certificates for the program.
So we give kind of a title, which is, for the students that participate, they're a Data Science for Social Good Fellow. And that is a title that they can then use on their resumes and transcripts. There isn't, in terms of participating, we don't have a badge per se, or a continuing education kind of credit program.
So the same thing, I guess, as Stephen, I know that it's a program that's part of the museum, but do you assess, how people are engaging with it, and what type of impact it might be having on the kind of broad population that you see?
Yeah, so we think about this in a couple of different ways. We don't give a grade for anything that we do, but what we do is we do evaluative studies of what people learn. We do a lot with artifacts, with sort of narrative, analyzing narrative. We do observations. We do pre and post surveying and interviews, and we also do what are called think alouds, in which we actually, while the subject is engaged in the activity, they're actually talking about what they're thinking. So that's one whole area that we're dealing with in terms of doing evaluative study, and that's primarily done for our sake. The subject doesn't necessarily get a grade or any kind of evaluation out of it. We report that to the government and to our leadership here. And then the other thing that we do is where we're involved with digital kinds of experiences or programs that actually can record the interactions with the subject. We go through and we look for learning in digital logs through things like click streams and also sometimes we do eye tracking, that kind of thing. But the main purpose is for us to understand whether what we're doing is effective and is having impact. And as far as what the students get out of it, so some of our programs are actual programs we run with schools and with students, and they get a certificate, and they're, you know, we generally get pretty much 100% participation. Typically, a student that isn't doing well will just drop out because these are very intensive kinds of things that we do. The term was used before, boot camp. We call them that, and you know, in general, we don't give badges or that kind of thing, but we do give certificates, which kids appreciate. And again, the age group for this is primarily probably high school and early college, but not you know, not specifically targeting undergraduate, but preparing them, I guess, as undergrads. That's primarily our sort of sphere that we work within.
Nice. Nice. So we have the 5 minutes left for the panel, and I have a question for each of you. So it's 5 of you, and it's 5 minutes, but it's really a broad question about envisioning the future for data science. So for data science to thrive and to be the data literacy that we see we need as a society to push forward innovation, to push forward work, how do you see or envision a future where some of these what could be considered alternative mechanisms, whereas outside of education, can connect to really broaden and change the educational sphere around data literacy or data science, and how it can remain inclusive? So a vision of, you know, how we could work together with traditional programs as well as initiatives or museums. So I'll kind of start line or let someone pick, but really kind of your, what you might think would be an ideal or a good way or a good outcome for it to end up in for data science.
I'll start if others, you know, want to give it a minute. So I think I kind of covered the overarching objectives in my slide deck, but you know, in our world of worlds, we get this this very inclusive participation from the industry, and as the industry is moving along, we're sort of moving along in how we understand what the needs are of the workplace, and we begin to really catalog and bring programs along that fill those gaps, and also identify gaps that are appearing, because things change over time, and be able to find ways to be very nimble about how we fulfill those. So really having a dynamic process for moving along with the industry and tracking that well through our educational programs and informal learning, you know, lifelong learning.
Nice. Yeah, thank you.
Yeah, I'd like to add one of the things with data science, just like many other fields, there's this much you can learn from the textbook. You do need the hands-on experience when you go out. You do need, and there's a lot of, just like we heard today from almost all speakers, there's a lot of emphasis on the hands-on experience. The thing is that it doesn't necessarily need to be outside of the traditional programs. The traditional programs can change and can incorporate those things in the classroom as part of the of the program. It's starting to happen, and higher education is starting to take that path. Yeah, it happens slowly. Higher education is a conservative field, so it happens slowly. It changes. First, you see like anecdotal changes, then you see larger, bigger programs, and now you see that trend. But it is happening in some other fields, not necessarily data science. Can happen in data science too. To have all those good practices, bring them to the classroom, not separating the traditional programs from the hands-on experience that we need so much.
Yeah, that's a really good point.
I'll go. Oh, sorry. Go ahead, Sarah.
Oh. Well, I was just going to say, I really agree. I think, we get the question a lot, once these programs are in university curriculums, college curriculums, is there really going to be a need for these types of, less traditional programs? And I think there always is, because as, the wealth of panels on this webinar have noted, these programs fill gaps that will continue to be there. Because not everybody has access to these, academic courses. And it also, these other programs, and especially integration across these programs, allows us to work across so many different sectors, across different populations, tackle questions of getting this sort of education to diverse populations. So I think these programs really serve an important role, and that's likely to change over time as we have more sort of academic programs in place, but I don't think it's going to go away.
All right. Tracy.
So I'll be brief. So I love this question because our vision statement is building communities teaching universal data literacy. So we do have a vision of the future that includes everyone knowing about data. And how we get there, I think there's all these programs plus many more, but the community aspect is key. And building up people from all different backgrounds and experiences to have these skills and support each other and be a part of this broader data community. So a lot of different ways to get there, and that's why I love panels like this.
Fantastic. So
Al? Okay. Oh, yes. So part of the thing I've been trying to communicate is that we've had to begin with educating our actual members and our board. And for the students, our enrichment programs allow us to bring data science education into their experience as a part of our program. The fact that our instructors actually teach in the schools allows us to bring that into the school, and we are beginning to work with starting with the principals of those schools, and then with the math instructors and others, to bring that more into their normal education experience. So it is a process for us, and I'm very happy to be a part of this webinar and hear things I did not know existed in terms of resources, so that we can do better. And so I do see this as becoming a standard part of what we do for our students and for that community around those students. So thank you.
Nice. So, I mean, I'd like to thank all of you. This has been a really rich panel, I think, for listening to all the things that are going on and happening in this space. As we move forward, as I said, this is the second webinar in the Keeping Data Science Broad. Also, the website for the series is in the links for this description of this particular YouTube video. And we'll post more webinars as we are partnering with the National Academy of Science as they're doing a study on this topic of envisioning the future of data science. And so there's going to be a series of webinars. There's already been some workshops. And really, my goal is to make sure that this discussion of data science even stays as broad as this panel and other things that are going on, so that it doesn't become pigeonholed in a certain type or a certain particular type of mechanism for going forward. So that's another benefit to filling out the input form, but also to coming back and viewing some of the other webinars that will run through the National Academy of Science, which will be posted on the website. And if you want to get more involved in the hubs, you can visit any of our web pages. You can go to the South Hub. I think we also have links to the West and the Midwest and the Northeast Hub. And you can get involved in the education and workforce working group. Mostly it's projects as project teams. So as people do projects, you're a part of the working group, and we'll try and help you facilitate with either collaborative workspaces or connections to other great people doing work in this space. So thank everyone for watching, and also thank Costa, who has been technical support for this, as well as Beth and Donalyn, Costa from No Innovation and Donalyn from No Innovation, who do fantastic work, as well as Beth Russell, who's been a consultant with the South Hub for some of our education programs. She is also fantastic. So thank you all.
Thank
Thank you,
you.
Renata.
Hey, thanks.
Thank you.
Bye-bye.